Welcome back to this Megaminx PLL series. Today I'll be covering these three cases, including their mirrors. Let me just show you what it is. It's known as the evil cases on the Megaminx PLL site. This KEPLL, so the one where there's always one edge that's oriented, and this corner. So this E-perm, so these bars are opposites. Also enough, it's this cycle again, so there's always going to be one solved corner in this case. Yeah, so what that means is it doesn't matter doesn't matter there where you execute these arcs, it will always work out. Yeah, so it comes in, so this one, lots of blocks, as you can see. It's always going to be the same PLL. Yeah. This one, it's a bit hard to recognize, but it's either the solved edge and the solved corner are a nice move away, or not, yeah. And then the last one is opposites. This is a cool one because if you were to draw it out on paper, you would see that these swap. It's like an F-perm kind of thing. Yep. Okay. Cool. So I'm just let's just start off with these ones. I should have set up better, but. I think I did have this one. So here it is. We have the clockwise version of it, which is the solved pieces, the blocks, is the edge and the corner on the right, and over here you have the opposite, or the mirror, where the corner is on the left. So I'll be going over these algorithms first. Recognition, pretty straightforward, just don't mix it up with like this case here. Don't mix it up with the other block heavy cases. Just remember that this is the only case that are blocks and have this KEPLL. So I'll do this one first. The algorithm will be at the bottom of the screen. Yep, so yeah. Yep. And the second algorithm, the right-handed version, or the left-handed, sorry, goes anti-clockwise, will also be on the screen. There. So it's recognition, just don't get these two cases mixed up. Just know if it's the one on the left, you do the primes first, and if it's one on the right, you do the normal ones first, I guess. Yeah, so that's that one. The next cases we'll be going over is this case here, and I'm going to do the mirror over here. Yep, here it is. Now you're probably wondering, how do you tell these two cases apart? They look very similar. That is true. They do look very similar. As you can tell, it's always going to be one edge, one corner solved. Yeah. So the way to tell the difference is just find the AOF such that the front face is matching, and then you figure out is it right-handed or left-handed. This is left-handed because it's on the left, this is right-handed because it's on the right. The handedness doesn't really say much, I just like to use it as a recognition case. It doesn't mean I execute one arc with my right, one arc with my left. That is possible, you can do that and lower the amount of arcs you need to learn, but the arcs are similar, it doesn't really matter. so the right-handed case is on the screen. Yep, so it's... Oh, there's a typo. Yep, so it's Y, and then R2, U2, R2 prime. Yeah, there's that weird B move, B prime there, so... Yeah, so... What? I may have stuffed up this case. Yeah, that's the algorithm. Over here, we have the left-handed version. Again, recognition is just know that it's a KE PLL, and it's... a way you can recognize this is see these matching corners. They'll always match, doesn't matter which orientation. Yeah. So these two, so it's OU prime Y, R2 U2 prime RU U2, and then fix. Yeah, so that's that case there. I'll do it one more time, just show you the difference between right-handed and left-handed. Over here, right-handed is there, so it means... Now, a key point that I should probably mention is, usually, most of the time, it doesn't matter if you start off with an R2 prime, or an R2 or an R2 prime, because they'll execute the same algorithm nevertheless. Here, it doesn't matter. You have to do whatever the algorithm shows you to do. The reason being is, you don't want to affect this, corner, so that's why, I mean, you don't want to affect this corner here, this bar, so that's why you have to use this line instead. Yeah. Alright, the last case is the fun case. As I said before, it's basically like a massive F perm, and another thing that's cool is there's always going to be a checkered pattern. So these three are a checker pattern, 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 these three are a checker pattern. So you can use that as a recognition source, but I just go, okay, it's K, and this to are solved, and these bars. Yeah, so the algorithm is on the screen. Pretty sure there's no typos there. So it's B prime U2 prime, R prime U2, and then R U prime R prime U prime R U2, B, and then you solve this PLL, this OLO, sorry. Yeah, do it again. I mean, you can do that, if that floats your boat. Yeah, so I've separated it, and so that this is the OLO, this is the setup. Yeah. That's the other cases. I hope you enjoyed this, and I'll probably make more soon. Bye.